Alright, we're going to have a look at exact values here for theta of 30 degrees, 45 and 60. You should know how to work out sine, cos and tan for angles of 30, 45 and 60 as exact values, okay? So the first thing is you can see there's two triangles here, and these two triangles are what we use to work out these different values. Now these two triangles are on your reference sheet, so you can use them on your reference sheet, but I want to just quickly explain where they come from. So if you've got a right angle triangle that's isosceles, meaning that these two angles have to be equal, because angle sum of a triangle is 180, that's 90. These two are equal, so you've got 90 divided by 2, they have to be 45. And the most basic values I can have here is 1 for the two sides that are equal, and if you use the Pythagoras theorem you get root 2. That's where that first triangle comes from. The second one comes from an equilateral triangle, side length 2, and the reason why we make it 2 is because we're going to split it down the middle and make this 1, 1. Okay, and then from equilateral triangle, the angle is 60 degrees everywhere, and this one that we've split down the middle will be 30. And then by Pythagoras' theorem, if you use Pythagoras' theorem on this triangle on the left, you get that this is root 3. So that's where this triangle comes from. Okay, but really, you can memorize the two triangles if you want to save yourself a bit of time. And not have to keep looking up your reference sheet, but they are on the reference sheet, so you don't need to memorize them. However, I would heavily recommend you to memorize them, but know that they're there on your reference sheet. Okay, so from this, what's sine theta when theta is 30 degrees? We're looking at 30 degrees, that's opposite over hypotenuse, that'll be a half, okay? What about cos when we're looking at 30 degrees? Adjacent over hypotenuse will be root 3 on 2. And tan of 30 degrees is opposite over adjacent, which is 1 on root 3. Okay, you can rationalize this last one, but usually I just leave it unrationalized for this basic case. But you can rationalize it to root 3 on 3. Next one, 45 degrees. So we'll be looking at one of these two 45. I'm going to look at this 45. Doesn't matter which 45 you choose. Sine of 45 is 1 on root 2. Cos of 45 is adjacent over hypotenuse, also 1 on root 2. And tan of 45 is 1 on 1, which is just 1. 60 degrees. So looking at this angle here, this 60. Okay, sine is opposite over hypotenuse, root 3 on 2. Okay, cos is adjacent over hypotenuse, which is a half, and tan of 60 will be opposite over adjacent, which is root 3 on 1, or just root 3. Okay, some people rationalize these two middle ones to being root 2 on 2 and root 2 on 2. Actually, some people like doing that because then you can see a bit of a pattern here. You got a root 3 on 2, a root 2 on 2, and this is actually 1 on 2, which is the same as root 1 on 2. Some people help them memorize by that pattern. But I just like using the two triangles, okay? Some people do a little hack of squaring the answer in their calculator, like they might do sine of 30. Oh, let's say they're doing sine of 45. They'll write sine 45 squared in their calculator, and they'll see that that answer is going to be a half. Well, that means that sine 45 is going to be the square root of 1 on 2, which is 1 on root 2. So a little hack to use your calculator. You can do the thing squared and then square root. To be honest, I don't like this. Just either memorize these 9 values in the table or just quickly work them out from the two triangles and be able to quickly draw the two triangles. You use them so often you'll get used to them. And these questions just quickly draw in the degree symbol. Let's do these. Find the exact value, which means leave it in third form, of tan 30 times tan 60. So tan 30 is 1 on root 3. Sine of 60 Sine of 60 is root 3 on 2. Okay, so we can see a cancellation of the root 3 there. The exact value is a half. Next one, cos of 30 degrees, which is root 3 on 2, plus sine of 45, which is 1 on root 2. Okay, let's just rationalize that. We'll make a common denominator. So that's root 3 plus root 2 over the common denominator of 2. Alright. Let's do two questions here. There's a few questions like this in your textbook. Find the exact value of A for the following triangles. Alright, so these are two triangle problems. Sometimes it's good to introduce variables here. I see one triangle here with 60. I see one triangle here with the 45. It might be useful to have an extra variable here, call it y, and maybe an extra variable here, call it x. So let's, and then a will just be x minus y, right? So let's focus on working out what x is and what y is. Okay, so if we look at the big triangle and look at cos of 45 degrees, that's going to be adjacent, oh no, not cos, it'll have to be tan. Because I don't know the hypotenuse, I know the opposite, and I know the adjacent. So that's going to be opposite over adjacent, which is going to be 10 over x. Okay, now tan 45 is 1 on root 2. So I'm going to, no it's not. It's just 1. Apologies. Okay, so I'll quickly draw the triangles and that'll make it a bit easier. So tan of 45 is 1, so that's going to be x is equal to 10. Okay. Ooh, using the 60 degree triangle, we get tan of 60 degrees is equal to the opposite, which is 10 over the adjacent, which is y. So tan of 60, well, if you use your triangle here, 60, 30, it's going to be 1, root 3, 2. Tan of 60 is going to be root 3. So root 3 equals 10 on y. So y is going to be 10 on root 3, rearranging. So therefore my a will be x minus y, which is 10 minus 10 on root 3. Okay, now it says exact value. That's the answer, and that's okay to leave it like that, but you might want to rationalize and make a common denominator. So that's 30 on 3 minus 10 root 3 on 3. So you might want to make it 30 minus 10 root 3 on 3. Okay, we'll do another one. So this second question has two triangles again. Let's see what we've got. I've got I know this side is 10 and I know that's 60 and I know there's a right angle there. I'll focus on that triangle first and maybe I'll use it to work out some information. I can use it to work out, say, this side here. It's a right angle. Yes, I'm thinking what's the best way here. Yep. And also if that's a right angle, so that's 150, that'll be 30 degrees there, 90, 60, 30, so that'll be useful. Alright, let's first work out x and then we'll use x to work out a. So I'm using the big triangle around the outside with the right angle at the top. That's going to be 60, so that's opposite, and that's hypotenuse. So that's sine. Sine of 60 degrees equals to the opposite x over the hypotenuse 10. Sine of 60, using my 60 triangle here, is root 3 on 2. Okay, so timesing through by 10, that'll be 10 root 3 on 2, or just 5 root 3. So x is 5 root 3. And now I'm going to use the triangle on the right here, that's right angle with a 30 degree here, A will be the adjacent, and that's the hypotenuse. So adjacent and hypotenuse, that's cos. So cos of 30 degrees will equal to the adjacent, which is A, over the hypotenuse, which is x, which is 5 root 3. Cos of 30 is root 3 on 2 again. Okay, so it's A on 5 root 3. Cross multiplying, that's going to be root 3 times root 3 is 3, so it's going to be 5 times 3, 15 on 2. So A is going to be 15 on 2. Alright, you'll see a couple of those 2 triangle problems when you do your textbook work. So about 15 minutes to work on 2.4.